Assalamualaikum warahmatullahi wabarakatuh. My name is ABDUL HAKIM and I'm gonna present to you about our subject in our project, that is crane. So what is crane? Crane is basically a lifting machine indispensable to several industries, among them construction, shipping and manufacturing. A crane main purpose is to lift and transfer heavy loads. Designed around a number of constituents like the hose, a boom, counterweight, and outrigger. This machine uses static and dynamic principle of action, but in this present project, we are emphasizing only an understanding of the statics principle that keep a crane stable in operation. Next, we have common material used in crane. The first one is steel alloys. It's a primary material for load-bearing component due to strength and durability. Next, we have aluminum used for non-load-bearing parts like walkways and ladders due to corrosion resistance. The third part, we have advanced material like fiberglass and carbon fiber. It's usually used in light-duty crane component to reduce weight. Last part, we have cables. It's made from alloy or stainless steel because of high tensile strength and corrosion resistance. Now we move to objective. The first one is we have to study balancing force and moment that provide stability at the time of lifting or positioning the crane with a load. Next, we have to develop formulation for analytical models to ascertain the crane stability based on the load distribution, boom angles, and position of the crane on the ground. Lastly, we have to develop standard for appropriate crane configuration, load limits, and positioning that would facilitate operation under static conditions safely.
Assalamualaikum and greeting everyone. My name is AQILAH binti GHAZALI, AD240114, and I will be explaining the key concept of crane by using the static analysis. There are three statics engineering concepts that can be applied on the crane structure. Firstly, equilibrium of force and moments. In a crane, equilibrium is essential to prevent tipping or structural failure. All the forces, including the weight of the load, the tension in the cables, and the reaction at the support points must sum to zero. Similarly, the moments or torque about any point should be balanced. For instance, the boom and the counterweight are designed to balance the moments generated by lifting a load. Secondly, the load analysis. Cranes are subject to different types of loads, such as dead loads, which is the weight of the crane itself, lift loads, which is the weight of the lifted objects, and the dynamic loads due to the motion. This is because by analyzing these loads, it ensures the structural integrity of the crane and guides the selection of materials and dimensions. And lastly, support reaction. The base or support of a crane experiences reactions from all applied loads. Calculating this reaction will ensure the foundation or wheels that can handle the force without failure or excessive deformation. To make a point, tower cranes have a counterweight system to manage support reaction effectively.
Assalamualaikum and hi. I am Afif Syafi bin Muhammad Yusuf and my metric number is AD240112. So let's talk about the problem definition. First of all, we need to know how the construction crane functions. The construction crane utilizes lever and fulcrum and pulley system. The equilibrium of forces and momentum are ought to be maintained when the crane is functioning to avoid tipping to one side. The pulley system used by the crane is not this commonly used single pulley system, yet it made use of multi-sheave pulley system that distributes the load evenly to all the ropes so that the tension in each rope is not too high and can be withstood. There have been a few cases of crane tipping in Malaysia that sacrificed innocent lives and caused destruction of the surroundings. Therefore, the problem that has raised our attention is the crane instability that is resulted by non-zero resultant force and momentum. This sometimes occurred due to the lack of proper attention and care during calculation and estimation of the counterweight by the entrusted worker. If instability continues to be disregarded, then the probability of crane tipping increases gradually and could harm innocent lives. That is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is HEIKAL bin Hatta. So today I wanted to discuss about improvement of crane. So for the first, problem diminution of crane. For first, stability issues at greater height. Maintaining equilibrium becomes challenging as the height of the crane increase due to the force and momentum acting on the structure. Number 2, uneven load distribution. Improper use of the multi-shift pulley system or uneven load distribution can lead to excess strain on certain sections, increasing the risk of mechanical failure. Number 3, inadequate counterweight. Insufficient of improperly placed counterweight can compromise the ability to counteract force, leading to instability and tipping. So, from the problem of a crane, we got a solution for the problem of crane. First, unchanging stability at greater height. Use as one structural design like wider base and improve material to ensure better stability. Implement a real-time monitoring system to measure and adjust force acting on the crane. Number 2, ensuring even load distribution. Use a well-designed multi-shift pulley system to evenly distribute the load across all rope sections. Regularly inspect and maintain the pulley system to prevent uneven wear or failure. Number 3, optimize counterweight. Accurately calculate the required counterweight based on the load and crane height. Use automated system to dynamically adjust counterweight during operation for optimal. So that's all for the improvement of crane. Thank you for listening my presentation.
Assalamualaikum warahmatullahi wabarakatuh, and very good day to everyone, and also to Dr. Halim. So I here will present the conclusion of our project. The analysis of crane statics equilibrium underscores the critical role that static plays in ensuring the safety, stability, and the effectiveness of the crane systems. By applying the fundamental principle of statics, such as the equilibrium of forces and moments, engineers can evaluate and predict how the crane will behave under the different loading conditions. This case study highlights how proper analysis can identify the potential weak points in the crane's design and suggest improvements to enhance the structural integrity. Throughout this study, the equilibrium equation were applied to determine the forces acting on the crane, including reaction forces at the base and moments on the various parts of the structure. The result showed that even the slight changes in loading condition could have significant effects on the stability of the crane, particularly in the distribution of the forces along the boom and at the base of the structure. This illustrates the delicate balance that must be maintained to prevent structural failure, emphasizing the importance of careful design and accurate force calculation. Moreover, this case study demonstrates the limitation of simplifying assumptions such as treating the crane as the rigid body and assuming uniform loading conditions. While these assumptions are necessary for making the problem manageable, real-world conditions involve more complexities such as dynamic loading, wind forces, and material variability, which were not fully accounted for in this analysis. Future work could expand this model to include dynamic factors, further improving the precision of the crane stability predictions. The application of static principles extend beyond crane system and can be applied to a wide range of engineering fields. For example, similar techniques are used in building bridges, towers, and other large structures that must withstand significant external forces. Understanding how to analyze and optimize distribution of forces in these systems is essential for ensuring the safety and longevity of infrastructure. In conclusion, the static analysis of rigid bodies, as demonstrated in this case study, is a foundational skill in engineering. The findings from this study not only contribute to a better understanding of crane design and operation, but also reinforce the broader importance of statics in maintaining the safety, efficiency, and reliability of engineering system. By carefully applying the principles of statics, engineering can avoid costly failures, improve system performance, and ultimately contribute to the advancement of safe and sustainable engineering practices. That's all from us. Thank you.